Hello and welcome to the Genetics Podcast. I'm your host, Patrick Short. My background is in population genomics and studying the genetic causes of rare disease. I did my PhD at the Sanger Institute in the University of Cambridge and have been in biotech since 2018 when I started Sonogenetics. Sonogenetics helps academic and industry researchers to run large-scale genetic testing programs that speed up their clinical trials, generate data sets for the next big breakthrough, and give participants the best possible experience taking part in research. Each episode of the Genetics Podcast, we bring you insights from the leading minds in genetics and precision medicine, including household names and Nobel Prize winners, as well as early career scientists and biotechs working on the next big breakthrough. Whether you're a scientist, entrepreneur, executive, patient advocate, or simply someone curious about how genetics shapes our world, you're in the right place. Thank you for listening, and let's get started. Hello, everyone, and welcome to the Genetics Podcast. I'm very excited to be here today with Ben Goldacre, who's a doctor, researcher, science writer, author of the books that you may have heard of, like Bad Science and Bad Pharma, as well as I think you'll find it's a bit more complicated than that, which is a collection of essays, I think, from or articles from the early days at The Guardian. If you were a Guardian reader in the early to mid 2000s, you will have probably read Ben's Bad Science column. And this made him a little bit of a celebrity. And we were just talking before the call about he often is mistaken for a journalist who ended up as a researcher now. But actually, of course, the reverse is true. He's been a researcher the whole time, but has, I think, built a pretty admirable parallel second career around the public communication of science and when it goes right and when it goes wrong. So we're going to talk about a little bit of that today. But I also actually want to dive in on some of the recent really interesting things that I think Ben and his team have been doing around accessing very large-scale data sets in a way that preserves privacy and trust. And I think it's a very important topic right now. So with that, Ben, I just wanted to say welcome to the podcast and thank you for taking the time.
Hey, hi. Thanks for having me. It was video, otherwise I'd have shaved.
Yes, exactly. I tell myself this every day. My wife thinks I should shave a little more frequently. I want to just jump into the open data threads that I think you're focused on, and that you have a couple different projects that maybe you can tell people about. Could you just talk through some of the major projects, like I mentioned, OpenSAFELY, and there's some others I'm interested in, like All Trials and Open Prescribing, that you could talk a little bit about what you're focused on and the problems you're trying to solve.
So I'm Prof in Oxford and I run a thing called the Bennett Institute for Applied Data Science. And we are different to classic academic teams in a few ways. First of all, of course, we take large health data sets and turn them into traditional academic research papers. Everybody has to do that. That's how you prove your value to the funders and to the university that hosts you. But we're also interested in the practical use of data to monitor and improve care in health services. So, for example, we build tools like openprescribing.net, which lets any interested person come to the website and you can see exactly what's being prescribed in every single general practice surgery in the whole country. So 6,000 family doctor practices across the country. You can see what's being prescribed month by month down to the level of individual brands, individual chemicals, individual doses, and lots of interesting tools to make that data useful and informative to help people improve the quality, safety, and cost effectiveness of their care. So that used to be quite a normal thing for people who are interested in epidemiology, medical statistics, and public health to cross over with health services research. And in the 80s, you would find a kind of, a surgical outcomes audit or quality improvement project would get published in a glamour journal like the Lancet or the British Medical Journal. And then it has become less cool over the years, but we're keeping it real. We still think it's an important use of data. It's also an important political move. We don't do it cynically, but because we love using data to help the health service improve care for our citizens, that means when we talk to the health service about accessing data, they're interested in working with us because they can see that they get something back from us. The second way that we're a bit different is when we produce platforms and dashboards and tools, ways to work with electronic health records data, we don't do it just for us. We're interested in the science of the platform, of ways to make platforms in such a way that they are capable of managing the privacy challenges with data, the efficiency and reproducibility challenges with data, and we produce platforms for everybody to work on that data rather than just us. And then the last way in which we're different is because we do different jobs to other research teams, we employ different types of people. So we don't just employ researchers and clinicians. We also employ, currently about half of us, in fact, are software developers. Yep. Now, this makes a lot of sense to me because you manage and analyze data by writing code. And if you're going to write code, it makes a lot of sense to have people who do that for a living. And it makes a lot of sense to adopt the best practices that have emerged in the software engineering community over the course of the previous few decades. But it's still quite an unusual thing to do in a university, and you hit all kinds of interesting challenges, including around respect for those skills, actually, culturally, although it feels like a soft thing, it's a real issue. I put all our software engineers on any paper that they are involved in, and sometimes somebody will pop up and go, why are we putting this software and you go, oh wow, look.
I'm for an education session about what they do. Yeah.
Pull up a chair. Yeah. And on our grants. And also interesting challenges around how do you pay people?
Yep.
Because you don't pay them the same as the person who fixed the printer in the IT support team in your department, although that's also obviously a valuable job. It's just a different job. But equally, you're not going to pay people $300,000 a year. We tend to model our software developer salary scale on clinical academics. So this may not be a universal thing, but in England, researchers are paid unbelievably badly. Doctors are paid pretty badly. And doctors who work in research get the pretty bad salary rather than the really terrible salary.
Right. Yeah.
I don't enjoy that iniquity at all. But it's been our model for software developer salaries in an academic context. We say, look, we pay them the same as doctors because that is a set of technical skills and the kind of street knowledge that you get from working over a decade or more, but also with a big discount for public service, which is why it's your the NHS salary, which is what doctors in research get. So that's the Bennett Institute, and we are a little bit unusual, but we're a happy ship, and there's 35, 40 of us, depending on how you count, in Oxford and surrounding mountains.
Yeah, much more mountainous than Cambridge, where I am. A little bit flatter.
Oh, well, good for cycling. So you get to go on that hilarious cycle path where they've written the human genome in fading pink and yellow stripes.
Yes, that's right. I did my PhD out at the Sanger Institute, so that's like part of the bike trip out there, counting all those letters and trying to make sense of them. Yeah, it's really nice. They do need to repaint it though. It's been a long time.
Yeah, so that's what we do, and I guess the thing that maybe people are most interested in. Well, I don't know. Sorry, I'm steamrolling. You go.
No, I'm interested in hearing about. Maybe let's start with open data. Maybe you could talk a little bit about that because I think it's such a I had, for example, Lord James O'Shaughnessy on the podcast recently talking about what a amazing data resource that we have in the UK as a country, and we know that we need to figure out a way to safely make sense of that data and bring it to certainly researchers in this country, but hopefully people around the world so that we can make sense of it and make discoveries. And I think that is at the core of a lot of the work that you're doing here, but have also done historically of how do we, there's a trade-off. There can be a trade-off between security and usability of data, but there doesn't always have to be, right? So I'd love if you could talk about that.
Yeah, well, so I mean, the big project that we've done in this space, obviously, is the OpenSAFELY platform. So we built, I think, probably the world's largest electronic health records research platform where we've been able to manage the privacy and transparency challenges around accessing sensitive personal data, the entire nation's electronic health records. We've managed to address the privacy and transparency challenges to the point that even the most feral opponents of researchers having access to this data at population scale, like the campaign group Med Confidential, have written formally on the record twice to the Secretary of State for Health and Social Care saying, not only will we tolerate OpenSAFELY, we actively like it. And we've similarly had Royal College of GPs, the British Medical Association write actively, positively to Secretary of State supporting us. And we've also set out to address some of the efficiency and reproducibility challenges around working with this data. Do you think it's helpful for your gene-obsessed folk if I kind of describe what GP records look like?
Definitely.
Okay, so first up, in the socialist utopia of the United Kingdom, healthcare is funded through taxation and provided free at point of access. And GPs are family doctors. They're the gatekeepers, your first port of call. They're the people that you see the most. And they're spread across the country, 6,000 practices. And so in your GP records, there is this extraordinary reservoir of information. And in the nation's GP records, it's even better. So this data is both broad and deep, this electronic health records data from primary care. It's broad because it covers the entire population. So in England alone, that's about 58 million people. And England's electronic health records are particularly powerful because although there are a few other countries around the globe that have managed to get reasonably good harmonized electronic health records, they tend to be a bit smaller and a bit of a monoculture. Whereas the population of England is hugely ethnically diverse, which means that potentially the research that you do in English data is applicable to the entire world. Secondly, these records are very deep. So for every interaction you have with your general practitioner, there's very detailed information. So there's one row for every diagnostic code entered by a doctor, one row for every prescription and exactly what it was for, down to the level of the drugs, medicines, and devices dictionary code. There's one row for every blood test and its result. There's one row for every systolic blood pressure reading and what it was. There's one row for every appointment, its booking date, its execution date, a row for a referral letter being sent, all of that. So incredibly detailed information. And there is a trace of most of your major health problems that involve coming into contact with secondary care, because when you get sent home, you'll have a SNOMED code filed saying this person's had a stroke. So broad and deep data. Now, this data has enormous potential. Firstly, for research, you can do it to do absolutely everything you could possibly wish for in terms of epidemiology research at population level. You can look at the causes of disease, the consequences of disease, treatments. You can look at their effectiveness with all the caveats around non-randomized data. You can look at their safety. You can look at who's getting them and who's not getting them. So you can do things like some of our work on speed of adoption and diffusion of innovation in the health service. You can also look at speed of rational disinvestment and how quickly do people abide by instructions from on high in the NHS that they should stop doing.
Oh, interesting. Is that pretty slow? I guess it depends. Probably slow.
And the whole of medicine is fundamentally an oral tradition. So, you know, different things happen at different paces. And it's actually a very under-researched area, I think, what drives adoption and de-adoption of different treatments. And it's something that we've been trying to get funders interested in. And interestingly, it's the health service that are most interested, not the traditional research funders, which I think is a missed trick, but must never say anything mean about a funder. That's rule one. Okay, so amazing power for research. Amazing power also for service monitoring and improvement, because you can see for every citizen where they are. And so for every institution that they come into contact with, you can look at comparative rates of clinical events, so you can monitor clinical activity, clinical outcomes, and use that to try and drive improvement of quality, safety, and effectiveness and cost effectiveness of services. But this same data also presents enormous challenges. So I guess in our heads, we fit the challenges around electronic health records data at population level into 4 categories: privacy, transparency, efficiency, and reproducibility. So to take the first 2, these are problems for other people, not researchers. Privacy and transparency. the very data that you the very data you want to use because it allows you to save lives with your brilliant research, also by definition contains the most confidential medical records of the entire population.
Yeah.
Everything about every single person's hysterectomy, fertility history, mental health treatments, and so on. Now, every now and then people sort of make fatuous efforts to manage that by saying stuff like, oh, let's just take out all the sensitive codes like the mental health codes, which doesn't really work for a whole host of different reasons. Number one, that would mean no research ever again on the causes or consequences of mental health problems, which is a bad idea. No use ever again of mental health as a modifying factor, an interaction term or a mediator or a confounder in an analysis of other stuff. But also, while some people might be very embarrassed about a mental health problem, many people would say it's arguably prejudiced of you to even say such a thing, and I don't mind. Who knows about that?
Yeah.
So different people have different intuitions as citizens about which aspects of their medical records are sensitive, and different things will be sensitive to different people in different contexts and so on. So you've got to protect privacy whilst granting access, and that's a real challenge. So that was the first hurdle we had to overcome with the OpenSAFELY platform. At the beginning of the COVID pandemic, we wanted to grant a large number of researchers and NHS analysts to be able to run approved research and analysis projects on the entire nation's electronic health records, but you couldn't just take the names and addresses off and give them a copy to download, which is what's always historically been done with these large sensitive data sets. And you couldn't do that because that is no good privacy mitigation whatsoever. You only have to know a few things about a person, some key aspects of their medical history. So if you know that they broke their arm and then their nose and then had a treatment for an abnormal heart rhythm, and you know roughly when this happened, you might get a unique match. Women are particularly vulnerable to that kind of re-identification attack. So if you know that somebody was living in Hereford until 2003 and then moved to Oxford and had her 2 children in 2010 and 2014, and you know that because you know this person from work or from the school gate, just that information about where they were, when they moved, when their kids were born is often enough to get a unique.
Right.
And we have to accept that although, of course, most people are really nice, society contains...
We're not.
Yeah. And the more you have people accessing this data, the more likely you are to have bad apples. And we know for a fact that very tragically, people who are in trusted positions sometimes misuse records. So it's currently the 25th of March, 2024. And last week, a big news story was that we assume a healthcare professional working in the place where Queen Kate, Princess Kate was. Sorry, I'm not an expert.
The wrong guy. Yeah.
Anyway, the Princess of Wales, who's been in the news for health problems. It's a big news story that somebody illegally accessed her health records.
I saw that. Yeah.
A member of staff in the hospital where she was being looked after. And that is very common. I've seen it in many hospitals where I've worked. You see it a lot in the, there are a lot always, there's a steady trickle of newspaper articles. Yeah. It's often, creepy practice manager guy stalking his ex-girlfriend in the small town where they both still live. Sometimes it's somebody looking for somebody to whom they were an abusive partner and trying to find out their new location. So we do have to be thoughtful about that. And that's not an insult to epidemiology researchers or data analysts. It's a simple practical fact. It is reasonable for the public to be concerned and to want there to be good safeguards around their records. And the only question really is, how do we square the circle? How do we give a large number of people access to the data whilst also protecting privacy? Now, we invented, and we may not have been the absolute first to come up with this idea. People who work in computer science might say, well, using test data is not the most amazing alien idea ever. But we came up with a pretty neat idea and implemented it critically in a working set of tools that actually exist in the world and are genuinely used by people to address these privacy challenges and grant access. So the first big move that we made was instead of giving people real electronic health records data, but with the names and addresses taken off and replaced with a pseudonym, we give them randomly generated dummy data. So this is data which is structurally similar to what they would have used in running their analysis, but completely randomly generated. So it's good enough for them to write and then test their code, the commands telling the computer how to prepare the data, how to analyze it. So the statistical models or the graphs or the tables that they're going to produce. It's enough to catch problems like you've put a comma in the wrong place, you've called a variable that doesn't exist, you've used a capital letter in a language that gets cross about capital letters in the wrong place. It won't catch every possible eventuality with your regression models not converging because some variables are collinear or something, but it's pretty good for testing that your data is capable of running to completion. Yeah. So you write your code using only randomly generated dummy data on your own machine. Your code synchronizes to GitHub. And then when it's been tested, you've got all the green ticks. You know that your code is capable of running to completion. You press a button in the OpenSAFELY platform. You tell it which GitHub repository you want to run against which data set. And your code gets wrapped up inside a container using a bunch of standardized Docker images. And it gets sent off into the secure environment that contains the real patient records. But no researcher or analyst ever needs to enter that environment and interact directly with the raw records. And then your outputs folder gets filled up with your log files so that you can check that you've, work out why your scripts all failed.
Yes.
Or, God willing, your graphs, your tables, and the outputs of your statistical models. So that's our big privacy mitigation. Yep. And it works pretty well. It's not, to be clear, the same as using synthetic data. So synthetic data is the term that people use to describe when you take real data and you add just enough statistical noise to change the dates around or randomly make people pregnant or not pregnant. You add just enough statistical noise to protect citizens' privacy, but not so much that you destroy the true statistical relationships. I think that's a blind alley. I understand why so many methods people are going down that blind alley, because it is a methodologically fascinating blind alley.
Yeah.
Ultimately, it's just never going to work out for you because the more noise you add, the better you protect privacy, but the more you mess up the true results. And you've got to really tailor which things you do and don't add noise to according to what those variables are. Like if you add just a few days to an event, that's often fine, but sometimes catastrophic because your analysis might be, is the time from this medical problem to this medical intervention within the 4-day window that it should be,
right,
with national treatment guidance or best practice. And if you've been randomly adding a few weeks to both of those dates in order to permit the data to protect privacy, you've really messed that up. So that you've got to have incredibly complicated, tight conversations constantly about exactly how you're permuting it. I mean, it's a universe of manual expert labor, and I just don't think it's viable.
I had the same instincts on this as well. It seems like you sort of have to know the structure of the underlying data
and the analysis
in an omniscient way, and the analysis to perturb it in the right way. And we don't know that otherwise. We wouldn't need to do the analysis, right? Yeah.
I mean, it's so much work, but like I said, I can really understand.
Yeah.
Researchers are like a sort of shoal of fish, or like a sort of starling murmuration. Like a few people go, hey, this looks fun. Okay, I'll follow you. Oh, wow, no, this is great. Oh, gosh, look. Oh, God, synthetic data's got a lot in common with power calculations in a funny, yeah, it has. And you can just see, you can see why so many
it's an interesting technical problem as well, right? And you can just become obsessed with the technical problem and forget about the thing you're trying to do, right?
Exactly, yeah. So we built our platform in this way. And the first thing that happens when you do that is people say, yeah, that sounds great. But back in the real human world, we've often been told all kinds of fairy stories about privacy protections. So this sounds good in principle, but how do we know you've really done it? So to manage that, first of all, we put all of our code in public on GitHub. So if you go to github.com/OpenSAFELY-core, you will see the entire code base of the OpenSAFELY platform, free and open for security review and scientific review and efficient reuse as a publicly funded artifact, funded by UKRI and in particular by Wellcome. So that addresses privacy pretty well. The second challenge you get is then on transparency. So privacy campaigners, professional groups, patient bodies, people reasonably say, look, we believe that you're managing privacy, but people could still be doing something with the data that's outside of what they've got permission to do, right? Yeah. Maybe you give somebody permission to do one kind of analysis and then they disappear off and they're doing something else. It could be outside of the terms of their permissions. It could be that they're doing something that people don't feel happy with. Like, the kinds of anxieties people have are, you give the Home Office some data to do something on policing and health, but then what happens if they suddenly start doing something about immigration or something that they didn't have permission for? That's just an example, right? A prototypical imaginary example of the kinds of worries people have. So what we wanted was to be as transparent as is humanly possible. And so we set the bar very high. We thought, what if you were completely and perfectly transparent? And so that's what we've done. If you go to jobs.opensafely.org, you will find an open public website where in real time, you can see all of the jobs that are being executed against 58 million patients' electronic health records. And for each job, if you click on that job, you'll be able to see more information about who it is, where they're from, and so on. Now, normally, what you would get is a one-paragraph free text narrative description of the project. Cardiovascular disease is really important and kills lots of people. We're going to find out which drugs are best, that kind of stuff. We have that, but we also, because the code is all publicly accessible for every analysis run in OpenSAFELY, because people write their code at home using randomly generated dummy data, and then they put it on GitHub, and then they submit their GitHub repository to run against real data. Because their code is already on GitHub, we also post a live public log of URLs of GitHub repositories that are running against patients' records. Now, sometimes the contents of those GitHub repositories is open immediately, even while they're running. In fact, many, many times. Those are brilliant, brave, open, transparent researchers who are basically doing the equivalent of having their Google Doc open while they draft their paper, and good on them. We allow people to keep their GitHub repository closed while their code is running, but as soon as they share any results anywhere, preprint, literally anything anywhere, that GitHub repository gets made open.
Yeah.
And we're in control of which.
Wow, that's interesting. That's really interesting.
So this is not just a kind of social norm around openness. This is openness as part of the default mechanical operation of the platform. Yeah. You cannot covertly run code against patients' records. You can only run code against patient records via a GitHub repository, which is either open or that we will make open. Yeah. And the public log, furthermore, doesn't just link to the GitHub repository, it also links to the commit ID of the GitHub repository. So GitHub repositories are dynamic, they change over time, but this is an open public log of the precise state of the code at the moment that it ran. Now, from this flows an enormous amount of cool stuff. For example, one of the great challenges in research is people engaging in undisclosed p-hacking. So you run the same analysis 100 times until you get the answer you want. And you can hear this echoing down the corridors of epidemiology departments the world over. Oh, it's p equals 0.058.
It's trending. It's trending significant.
How about if we did age in 5-year bands instead of quintiles? No? Okay. Maybe if we used age as a linear variable, that doesn't really fit the nature of that. No, but why don't you try it? Oh, 0.048 for p. So now, great. Okay. Shut up shop. Yeah. Strike the tense. Our work here is done. And off goes your paper. Now, that kind of undisclosed p-hacking is pretty common. You could do that in OpenSAFELY, but you'd be pretty stupid too, because you would be doing it loudly and flamboyantly in full public gates, because every single one of your peers, if they want, can go and look at your project ID in the OpenSAFELY log and would see that you ran 100 near identical analyses until you stumbled on one and then published that one. So it's very good for that aspect of reproducibility. But then there are also some other things that we had to do around efficiency as well as reproducibility, which further augment the openness of the platform, but also the helpfulness of the openness of the platform. So to understand that, you need to understand a little bit about what a soul-destroying and awful experience it is to work with electronic health records.
Right. I have done a little bit, but my soul is not yet destroyed.
Well, so I think one of the first things that happens when people approach it afresh is they ask entirely reasonable questions like, okay, where's the variable called has diabetes?
Yeah, right.
And you go, well, there's the rub, because it's your job to make that, right? People sometimes say electronic health records are dirty data. And I feel weirdly defensive of this data because it's not that it's dirty, it's that it's not made for us. We are parasites, we're secondary users. So I'm a doctor. These electronic health records, which I have created over 20 years here and there, these records are an aide-memoire. They're a practical record for doctors and patients to keep track of what's been done in the past in order to help inform practical choices today with the patient about what's the best thing to do next. They're not made for researchers.
Yeah.
They are this amazing resource for doing data analysis and research and quality improvement work and life science innovation, but we should respect and understand the fact that we might have to invest a few million quid in getting them into shape, given that what's contained in there is billions and billions of pounds of untapped value. Now, in some respects, it's almost better to think through a really tangible example to understand what you have to do to prepare an electronic health record. Let's say you were trying to create a variable that says child with asthma, right? So an amateur would approach this problem and go, okay, fine. There's a bunch of SNOMED diagnostic codes for asthma. I'm going to search for the word asthma in the SNOMED code dictionary. I'm going to find all of the codes that contain that word. And then I'm just going to do a quick search. And if you've got a SNOMED code for asthma ever in your record, then I'm going to say you're a yes for asthma. And if you haven't, then you're a no. Now that's going to fail in a number of different ways. First of all, you've got to write those code lists very, very carefully. I've lost track of how often I've seen absolute howlers. First up, by the way, only 2% of all electronic health only about 2% of all health data research papers actually share their code at all.
Yeah.
That's from the most current systematic review in the British Medical Journal last year, 2023. But where you can access people code or code lists, you often find real howlers. Like you'll find their list of SNOMED codes to identify somebody as having high blood pressure include every code that's got hypertension in it, including ocular hypertension,
right,
including pulmonary hypertension. So those code lists themselves need careful authoring and checking. But then secondly, they're often not enough in their own right. For example, if you want to say this is a child with asthma, if you include every child that's ever had a diagnostic code for asthma, you will be wildly over-inclusive because there are huge numbers of children who've had a diagnostic code for asthma entered. They get blue and brown inhalers once, and then they're never seen again until they come in to get stitches taken out from a dog bite 6 years later or something, and the SNOMED code for that appears in their record. Is that a child with asthma? I would say almost certainly not. So if you want to create a variable that says child with asthma, first of all, you've got to make a decision. Do I want a really sensitive but over-inclusive definition of child with asthma? Do I want a very specific one with few false positives? And then you've got to come up with some code lists and some rules to implement it that will go something like, make a variable called child with asthma, make it 0, but make it 1 if a person has at least one asthma diagnostic code in their record ever, and at least 2 separate prescriptions for blue and brown inhalers within the year of interest in this analysis.
Yeah.
So that's the kind of data management work that you have to do if you're going to work well with electronic health records. Now, historically, people do that behind closed doors in their own way, on their own laptops, with their own small cuts of a small number of electronic health records from the total population, and very rarely share their work, very rarely share their code. That brings huge problems. First of all, it means often people don't do it very well or invest the time and effort in it that it deserves, because it's never going to be seen by anyone, and you're just going, okay, come on, Tom, we've just got to get this thing done now. Come on, stop gilding.
Pick the asthma definition and let's keep moving.
Yeah, exactly. Secondly, when people do it, everybody does it in a slightly different way. So nobody's code is really readable to anybody else. And they won't even do it all in one go. So it's not like there'll be this beautifully styled self-referential SQL query. There'll be some kind of SQL query that will only work on your own personal local copy in a Postgres database of this electronic health records cut. And then that will produce some kind of CSV that's a bit of a stripped down list of all of the codes. And then you'll ingest that, and maybe you'll do some dreadful for loop in Stata or R to peck out the variables and use some weird statistical programming language thing like eGen in Stata, or something that you sort of learned on an EPI course 10 years ago to manage your data. So it's all very idiosyncratic, very anarchic, frankly. No culture of sharing, but also even if people did share, they could barely understand what each other were doing. Now, at this point, I wouldn't be surprised if you were like losing listeners like flies, because it sounds so boring, but this is the business of working with health data, right? It's the bulk of the work in any electronic health records analysis project. The bulk of the work is data preparation, and it is a huge strategic missed opportunity that we don't have tons of groups like ours bringing this kind of rigorous computational approach to building tools and standards to work on it.
Yeah.
So what we did was we thought, okay, we've got to standardize this. So we've built something now in its second generation called EHRQL, Electronic Health Records Query Language, which is a domain-specific language. This is a pretty common move, and there are parallels in Gene World. So we've got a domain-specific language called Electronic Health Record Query Language, which has all kinds of useful and interesting properties that I won't go into too much here, but things like it's compositional, so you can define a thing and then use it in another definition immediately. It is designed in such a way that if you're doing a common task, there's for the most part just one way to do the common tasks that thousands of electronic health records researchers previously did in a very different idiosyncratic way. It's also very well documented and very well tested, because if you go to the Bennett Institute blog, you will find, in fact, a whole article about how we do unit testing in EHRQL by Peter Inglesby, one of our great developers. And so by standardizing the tools that people use to prepare the data, but still allowing them to prepare the data in whatever way they wish, lots of great things happen. So OpenSAFELY as a platform now has 155 approved projects from 22 different organizations, most of them universities, but also UXA, UK Health Security Agency, Prescript, a quality improvement outfit, NHS England itself. And from this enormous community, they're all happily using our standard open source data management tools. So this is by a country mile the most widely adopted standard for working with electronic health records in the country, bespoke and created specifically for the opportunities and challenges of British electronic health records. It's also very useful for productivity, because if you can see what other users are doing for data preparation, and they're all doing it in the same way that you're doing it, then it's legible to you, it's understandable to you. So that means it's quick and easy to evaluate what prior users have done, think about whether you want to reuse it, or think about whether you want to modify it or fork it, repurpose it for your own thing. So that's one of the reasons why OpenSAFELY has been so productive. It also, by the way, gives you something called federated analytics out of the box. So we don't extract data and send it around. The raw electronic health records sit in the machine where they currently sit, and we build our tools as a layer on top of them. You can think of it as an incredibly specific and sophisticated query layer that sits on top of the data, but it doesn't just produce crosstabs, it'll also do a mixed effects logistic regression for you. Now, the challenge there is we built OpenSAFELY to be a portable open source set of tools that can be built in any data center containing electronic health records. So if anybody's listening who has a copy of some GP data for a consented cohort, for example, you might want to use just the data preparation aspects of OpenSAFELY and EHRQL on your local copy of GP data, because then you benefit from all the prior knowledge and prior tooling and all the evolving tooling now and in the future around GP data management and preparation and data quality checks and so on.
How much of this framework can be applied to other countries as well, outside of the UK?
So the stuff that we've built already is particularly well tuned to data where the generic class, I would say, is event list data. So images are their own challenge. Genetic data of all varieties is its own challenge. And by the way, both of those challenges, I think, are very well met, partly because there's a huge and diverse market, image in particular, of course, but also genome data. Whereas electronic health records data, much smaller market, and I would say a slightly more dysfunctional one, maybe, in terms of alignment of incentives and rewards and resourcing. So other countries' electronic health records will be very variable in the hospital data. Primary care data is often a bit more simple. The thing that's really nice about primary care records is that they were really bullish about the simplicity of it when it was first developed.
Right.
So not to get too sort of abstract, nobody should ever use the word ontology on a Monday, but there is no such thing, for example, as a property in electronic health records. There's no such thing as a person who has the state of having diabetes. There are only events,
right,
which are bound in time. So on this date at this time, this person was said to have this diagnosis by this clinician in this location. That's it. That's all there is. There is only events. Even ethnicity is an event. On this date at this time, this administrator wrote down that this person was British Bangladeshi.
Yeah, interesting.
They might have multiple consistent or inconsistent ethnicity events recorded over time. Whereas different electronic health record systems can get more fiddle and fuss, depending on what they're trying to achieve. So that's OpenSAFELY. And by standardizing everything and by having a domain-specific language for data preparation, first of all, the platform is resilient to people changing where the data is. What you often find is people are a bit reluctant to put a lot of time and effort into their data preparation work because they know that come next year, all the data that they have, whether it's HERS, the hospital episode statistics data, or something else, somebody in their organization will have decided it's a brilliant idea to put it in a completely different type of SQL engine. So none of their code will be portable, or the structure of HERS will that they're being sent will slightly change, or whatever it is. We wanted the computational environment in which the researcher or analyst was working to be stable, so it was worth them putting good time into building good code objects to share and worth testing them. But we also had to address the fact that in the first two places, TPP and EMIS, the two big electronic health record system suppliers, TPP, everything runs on tin. It's like literally a rack in a server. And in EMIS, it's a sort of gradually evolving set of things implemented in AWS. And so with EHRQL, electronic health record query language, you write your data preparation code once, it gets broadcast out by the OpenSAFELY machine, once to TPP, once to EMIS. It then gets parsed by the OpenSAFELY node inside TPP and inside EMIS. It gets parsed into SQL, which is capable of running in one place on Microsoft SQL Server, in another on a thing on top of AWS buckets. And it's parsed into something that will not just be capable of running, but ideally, where we've done it well and been able to do it well, will run efficiently, playing to the strengths of that particular database implementation. It's worth saying, by the way, that I've been rambling spontaneously about this, and it is a massive project, and it's a massive project that extends clearly way beyond me. I mean, Seb Bacon, our CTO, and Brian McKenna, our head of research and analytics, and billions and billions of people, dozens of people in our team, but also electronic health records researchers from London School of Hygiene, from Bristol, from Manchester, and also close collaboration with NHS England, who have always been the data controllers on the project, and that was really important to me. I don't like the fact that often an academic, a prof somewhere, becomes the data controller of a huge amount of patient data, either with or without their consent. I didn't want to be a part of that. I thought, the state or the NHS should be the data controller for this.
Yeah.
And of course, worked very closely with TPP and EMIS, the electronic health record system suppliers, both practically to work alongside them, but also technically they've got enormous amounts of knowledge about this data because they write the software that collects it. And then on top of all of that, we've also got Amir Merkar, who's a doctor and head of our IG team, who was previously interim chief medical officer at NHS Digital, who works really closely with the professions to make sure not just that they support us, but also that they understand what we're doing. So we work really hard to make what we're doing intelligible to people, because it is better than taking names and addresses off and disseminating copies of data out to hundreds of different places. It is better than having a remote desktop secure environment where you can log in and just muck around with the data in a fairly unconstrained way that's hard to audit. It's better than those things, but it's also a hell of a lot more complicated. Yeah. And so it requires a lot of talking and thinking. It also requires a lot of very, very profound collaboration across more specialties, deep knowledge than one person could possibly hold in their mind all at the same time. So it's one of those really fiendish collaboration problems. Yeah. Combines like so many different specialties. So the fact that it works at all, I must say, is extraordinary and an extraordinary testament to all of those people. But the nice thing about having to fix those problems is that we've had to fix big problems like the challenge of federated analytics, where you want the same code to run in different places against similar data, but in different locations. And also the challenge of portability. So if something changes in the NHS about where data is stored, everybody's invested lots of time and effort in building OpenSAFELY code. They'll still be able to run it as long as we build an OpenSAFELY engine on top of wherever the data is tomorrow. And there's nothing else really that does that.
Yeah, it's super interesting. I'm conscious of how much time we have left here. I was curious to just get a quick perspective from you as well on your career arc. You spent decades of your life writing some incredibly influential public-facing, not scientific in the sense we've been discussing today, but really helping the public understand science and all its flaws and shortcomings sometime. I wonder if you could just talk a little bit about what made you decide to take, I think, a intentional step back from more of the public-facing science, and you still obviously do an enormous amount of public-facing work now, but it seems like you made a choice at some point to say, actually, I really love doing research and I want to go back to doing that. And I'd love to hear a little bit more about that.
Yeah, I mean, there's always been overlap. So, I went to medical school and then did a bit of research, and then went back and was full-time doctor, and then was writing as a bit of a hobby on top of that, and then full-time research and part-time research and writing as a hobby on top of that. I suppose for me, well, so firstly, I'm a second-generation epidemiologist. My dad literally did the same job that I did in the same town. And I've not moved geographical location, which by the way, I really recommend as a lifestyle tip. You can really see, people think it's weird, but I think people mistake geographical relocation for forward plot movement in their life. If you're like, I am currently about 200 yards away from the field where we all used to go and hang out with, very cheap bottled wine when we were 17, and I walk there with our small children, and it's really wholesome and nice to just have all those different phases of the human
Mhm.
life cycle in one place. Anyway, I, I'm not sure how dissimilar any of this stuff is fundamentally. I mean, to me, I'm interested in how to use data and evidence to improve lives for citizens. And that will always entail understanding some practical technical stuff and explaining some practical technical stuff and explaining it to people who can act on it. So when I was writing the bad science column in The Guardian, it's interesting because people would sometimes talk about it as if I was engaged in this sort of mad philosophical project of dividing all of the newspaper articles ever written into the ones that were either right or wrong in what they said about science. And I didn't really care about which things were correct and which things were incorrect. The column was an excuse to talk about epidemiological methods, statistical methods, the right way of using data, with the gimmick of using your teaching example being somebody getting something wrong.
Right.
So, you know, a front page story in the Times about heroin use doubling in British playgrounds is an opportunity to talk about the research paper's failure to use Bonferroni correction for multiple comparisons, or correct for a sampling issue, or whatever it is. So it was really, it was pop science, pop epidemiology, but using people getting stuff wrong as the gimmick. And it was interesting and fun. I mean, I stopped really because I had other fish to fry, and also I had like twins, which is a sort of a time bomb going off in your life. So you got to pick one thing and try and do that well for a bit. It was also, though, and it's only recently that I've started thinking about it sort of retrospectively. I think I was quite lucky because I feel like I had the horror of the worst and most thrilling sides of social media.
Yeah, sure.
In a really big dose before most people. Like, I've experienced, and I suppose participated in, pylons for a really long time. I also, I suppose, I would really recommend my level of highly contextual microfame. Like, when I was on telly a bit and doing a lot of public lectures and theatre shows, people would fairly often come up to me in the street and say hi and introduce themselves. But they were also usually the kind of people that I'd want to talk to.
Right. You were epi famous. You were science nerd famous. Exactly,
Yeah.
which is good.
Or it'd be like, it wouldn't actually be people necessarily in the profession, but they'd be people who, if they'd seen you, it was because they were like interested and therefore interesting in some ways. Whereas friends of mine who are just straight legit famous comedians, hanging out with them in Soho at closing time is actually just quite annoying because you're having a conversation with a mutual friend about their fertility problems, and people are coming over going, "Hey, you're that guy. Can I have a selfie?" to your comedian friend, and I would find that really annoying. But yeah, I found it untroubling to potter away from that stuff. It's funny, in academia, if anything, it makes people probably more suspicious of you rather than friendly. Because, well, for all the reasons, but I think it's quite a good training ground actually as well. Being able to speak clearly and explain stuff is really helpful if you want to do good in the world, because you have to be able to do that with politicians and policymakers. But you also have to be able to do it across disciplines within a team as well.
Yeah.
Like, we're all lay people to each other, right?
Yes, that's right. Yeah, if you have a good team, you have a lot of diverse perspectives. You spend a lot of time explaining something that may be obvious to you, but not to somebody else, right?
Yeah. So yeah, it's I mean, I barely think about it now.
Yeah.
I might do some of it again in the future. I might not. I don't know.
Yeah, it's I mean, it's great. It's important to do things that bring you joy, make you happy. I certainly learned a lot today. I know that we're close to the end of time here, so I just want to say thank you. It was really helpful to do a deep dive into OpenSAFELY, learn a little bit more about that, and I feel like we could talk for 3 hours. You've got so much interesting things to talk about, so maybe we'll have a follow-up at some point, and we can go deep in another area. So thank you. I really appreciate it.
Hey, anytime. Bravo. Nice to meet you. And hello to all your people. Come to opensafely.org to read about that. Go to docs.opensafely.org. You can read 70,000 words of technical documentation. You can start using the dummy data off your own bat. You can throw up a development environment in a web browser. You can't run your code against real patient data, but you can start developing it against randomly generated dummy data. And if anybody wants to work with us, our eyes and ears are always open. So, and get in touch.
Amazing. Yeah, thank you. And thanks everybody for listening. As always, we will see you next time. That wraps up this week's episode of the Genetics Podcast. I'd like to give a huge thank you to our guests for sharing their valuable insights and experience. And thank you as well to our listeners, as always, for tuning in. If you enjoyed today's talk, the number one thing I would really appreciate from you is if you could share it with a friend or colleague who you think would enjoy it as well. We would also really appreciate if you could subscribe to our show and give us a quick rate and review on Apple Podcasts, Spotify, or your favorite podcast platform. Both of these things help us become more visible when people search for genetics and precision medicine podcasts. And we're always eager to hear from you. Please reach out to us with any questions or feedback on social media. You can find Cynogenetics on Twitter, LinkedIn, or visit cynogenetics.com. Finally, a big thank you to the team behind the scenes who make all this possible, in particular Amy Cousins and Sonia Shah who produced the show, and James Pierce from Selected Frequencies who handles the audio engineering. I'm Patrick Short, your host, and it's been a pleasure. Thank you, and we'll see you next time on the Genetics Podcast.